Hello everyone and welcome to the first video. Actually, what I'm going to do today is to solve a sample exam of a data structure. This exam is a sample exam for the fall semester 2010 in AUL University. As you can see, the exam will be 2 hours long and will consist of 4 problems. Today, what I'm going to do is to solve the first set of problems, which are true-false problems. Okay, so let's begin with the first problem. So it's a true-false, as I said before, and let's begin with the first one. A pass-by value is carried out when you pass an array as an argument to a function. Actually, this is not true, because when you pass an array as an argument to a function, you pass it by reference, not by value. So if you want to put something here, you can put false. Here it's false, and so here it's false. This is false, and you write here pass by reference. Okay, question number 2. It's also true or false question. When you store a linked list in a file, you save only the data. You don't need to save the pointer. This is true. Why? Because you don't need to save the pointers. This is true because when the pointers contains addresses and it changes every time you load the file to the memory. So you don't need to store the pointers. What about question number 3? A circular linked list is a good ADT to be used to give access control to a set of users shared a resource. When you share a resource, suppose you are sharing the CPU, for example, and you have a set of processes here. You share this CPU for a certain period of time, then you want this process to end and go back. Okay, so you can use a circular linked list. So when the last one is done, you start from the beginning. So you want, so this is true, and you want a circular linked list to apply for this. A double linked list allows you to traverse a list in either direction. This is true. The last node is also connected to the first node. No, it's in a double linked list, the last node is not connected to the first node. Actually, in a circular double linked list, the last node. So this will be what? This will be false. Okay? Let me now clear the window and continue with the rest of the questions. A container cycles through the content of an iterator. Actually, this is not true. An iterator cycles through the content of a container. So this is false. Okay, one difference between a stack and a queue is that stack uses 2 ends of structure. Queue uses only one. It's totally the opposite. Actually, the stack uses only one end, which is the top, for push and pop. Do you remember these 2 operations? Push and what? And pop. So this is false also. The first in, last out. First in, last out is the best operation that describe a queue. Actually, a queue is first in, first out. And this describes a stack, not a queue. So this is also false. Big O notation enables you to analyze efficient algorithm regardless of the computer speed and programming skills. And this is true, because big O notation is a mathematical notation. It does not depend on the implementation at all. So it's a mathematical notation. It does not depend on the implementation. So this is true. Let's continue now. Question number 9. Big O of log n algorithm is faster than big O of n algorithm. Since log n, we know that log n is less than n, so this implies log n is any algorithm that uses log n is faster than n. So here it's true. Since log n is less than n. Okay, so let's solve this example. The running time of the program fragment is big O of n squared. Let's see, here we have 2 loops. The first loop is iterating from j equal to 1 to j less than minus 1, and each time this inside loop here do some swapping and iterates depending on I, which is depend on j. So inside the second loop will not iterate by a constant number of times. It will depend on I. Okay, so for j equal to 1 till j equal to n minus 1, suppose j equal to 1, so I equal to 2, I less than n, so it's gonna iterate for n minus 1 times. This is the first time. Of course, it's gonna be multiplied by a certain constant here that I don't care about a lot, plus the second time it's gonna iterate for n minus 2, the third time n minus 3, and the last time it's gonna iterate for only one time. This is a series. We have seen this series 100,000 of times in discrete math in data structure, and this is equal to n multiplied by n minus 1 divided by 2, if you remember this series. So n multiplied by n, this here, we will have n squared. We don't care about the rest of the equation, so it's true. It's of order n squared, so this is also a true. The value of the leftmost node of the right node of the root. So let's begin with the root. This is root. Go to the right node, so you go to here, and then you go to the leftmost node of this one, which is 15. Is equal to 22. It's not equal to 22, it's equal to 15. So this is actually not true. This is also false. Okay, let's continue. In the previous question, the node of the value 12, this is one with the value 12, is the ancestor of the node with the value 2. Actually, it's not the ancestor. It's this is the node of value 2, and it's not the ancestor. The ancestor actually is the ancestor of the node with the value 2. No, it's the I can say it's not an ancestor, it's a predecessor, or sometimes it's called successor of 2, but 12 has no ancestor at all. 12 is not an ancestor of anything at all, so this is false. In the question, the node with value 40 is the descendant of the node with value 15. Actually, 40 is a descendant of 30, is a descendant of 19, is a descendant of 14, but it's not a descendant of 15. So this is also false. In the question, the tree is a complete tree. We know that in order to be a complete tree, it should have two properties. The last level, this level here, can contain nodes with 0 child, 1 child, or 2 children. But the other levels should be full. This is the first property. The second property, it should be completed from left to right. Here we see that it's completed from right to left, so it's not a complete tree. Is it a full tree? No, it's not a full tree. Since it's not complete, so it's not full. It should be completed all the levels. In equation, in the question 1.11, the depth of 3. Actually, it depends here on the book that you are going to use. In our lecture, we have used a book that says the depth of this one is 1, the depth of the second level is 2, the depth of the third level is 3, and the depth of the fourth level is 4. So this one of depth 4, it's not of depth 3. This is depends on the book that you are using, because some books uses this is depth 0, depth 1, depth 2, and depth 3. According to us, this is of depth 4. So this is false. Be careful to the book that you are using, okay? The minimum possible depth of a tree of 18 node is 4. Remember that 2 to power h minus 1. This is the number of the nodes that you can have when you have height, for example, h equal to 2 or 3 or 4 or whatever heights that you have. Okay, now the depth is 4. So replace h by 4. So we will have 2 to power 4 minus 1, which is 15. We have 15. Since it's 15, the maximum number of nodes that we can have is 15, and we have here 18, so the depth should not be 4, it should be 5. This is why this is false. Minimum depth will not be 4, it's gonna be 5. And this is also depends on what? On what do we mean by depth 4 or 5, okay? So let's now put here as a false, and let's continue in the next video solving the short answers. Okay, good luck on your exam.